Yeah, so I'm going to talk about kind of a board games as a domain for explainable AI. And in particular, I think chess might have, even all board games actually might have some added benefits, arguably. So yeah, so I'm just going to motivate it a bit and then talk about this and why I think chess is good and what the challenges are. And well, we all know about kind of AlphaZero achieving superhuman performance in chess and other board games. And the question is if the strong or weak AI, and that depends how you define it. And there was actually some of the early pioneers of machine learning basically set out the criteria for what is a strong machine learning AI. And getting there, we only met the first weak criteria there, where actually you have a system that learns, but we still haven't made much progress into the next levels, which is basically we must be able to explain it, and preferably in a way that we humans can learn from it. So this is what kind of the way that we are doing now with explainable AI. We are trying to understand what the system has learned and try to explain it so that we humans can benefit from it. So I say that AlphaZero is still very weak. We are talking about weak AI. And game-playing agents have many kind of benefits to offer for the explainable AI community. So far, when you talk about explainable AI, you mainly be talking about like model interpretability. Like you have a neural network or something that learns something and you're trying to understand what the network has learned. However, decision-making systems, typically it's both, you have some kind of a model, learned or otherwise, but you also have the think ahead process, the reasoning. And you are making decisions based on both the think ahead and how we evaluate the states that you get to. And this is basically like in board games and many other planning and many other decision systems. So explainable AI has so far almost exclusively just been talking about model interpretability. And this is where this term explainable search comes. I'm not sure I like the term explainable search, but I'm using it because we are explaining the decisions. We're not explaining the search, but the search process is a part of this decision making. And so when we talk about heuristic search, basically we have to we look at many possibilities, we reach a decision, and then we have to decide somehow explain why I took this path of actions. And that might not be enough because there could be another path that is more intuitive at first sight. So you might have to explain why that one rather than another one. So it becomes like a much more complex process where the model interpretability is just one piece in the puzzle of our explanations. And there are kind of unique challenges that come with this. And because board games are in ways intuitive, I think this is a very kind of attractive domain to do kind of explanation like this. And we cannot simply, when we are explaining the think that process, we cannot just simply dump out our game tree. Basically, we have to somehow find the right level of detail that we are going to, how we are going to explain this, so it's going to be still helpful, but not overwhelming. And so, yeah, board games, they both have this think ahead component and they have this model component to it, which is very nice. But chess has arguably, I think, some even more to offer. It's a very popular game in the Western world, and they're still getting more popular. And I think this is probably one of the main reasons. So the explainable AI community, when we're trying to explain decisions, one of the problems that we face is we don't know what an explanation looks like. What is a good explanation? There's a huge, very extensive literature in chess where we are explaining decisions for people of different abilities, from beginners to experts. So just the very fact that we have that, I think it's a great heads up compared to many other domains. Because again, like what is an explanation? Actually, it's not even clear. So an explanation, I guess, it has to be useful for whoever you're explaining it to, and that depends on the level of that person. Also, the difficulty, like chess is a complex game, and I don't, and we are a long way. Like we have to start by taking some baby steps, and but chess, unlike some other board games, that as you progress, they become more complex. Shoki, for example. However, chess, you can play that's like it's you can have going from like a very complex metagame position into very simple endgames where you have very, very clear explainable concept. I'm mating the king with a king of the rook. So we have also the way of scaling this to the difficulty level that we want. And so explaining decisions in chess, like I said, you have to explain both. You have to understand the position, you need to have the model interpretability, but also you have to be able to reason about the thinking process. And there are kind of, there were some methods that have been mentioned, how we do this for the methods for explaining the models themselves. I'm not going to go over that. I'm going to mention some work, though, that is of, and I noticed from your talk, there's already some work that I missed on this mini chess that I was not aware of, but they're using the same techniques they've been using here. This is a DeepMind paper, acquisition chess knowledge. I had my PhD in the paper at ITSCAI last summer, and then there's a recent paper out on also for DeepMind on archive. They're basically like they're actually trying to get grandmasters to learn. They're trying to understand novel concepts that AlphaZero learned and trying to see if grandmasters can improve from learning these concepts. And then there's also like Michael Lichtman's group has also a work on hex doing like similar things to the first DeepMind paper. And then again, the work that was presented, like references earlier also that are relevant. When it comes to search, there's very little relatively little that has been done. There is some work in planning. The planning community started to think about this back in 2017. And so they have been doing some interesting work that is definitely something that we should follow up on and read. That's very relevant for what we are doing. And again, it could very well be, to start with, it could be better to do explainable search in non-adversary domains. As long as we move into the sport games, we have in adversary domains, which actually make things more complex, but this is what, like, for this community, this is what we want to work in, though. And again, after what is an explanation, and like ultimately, you want this to lead to some type of a tutoring system, interactive system, where you can basically teach someone how to play chess at different levels. But then we get to this, like we don't even know yet how we are going to explain the search process. We saw some talk early, preliminary work on this that's being presented here, but just this highlighted very well the challenges, and we are just starting to look at that. And so that this may be not very much of concrete work being done yet. There's some, and also just some speculations what the challenges are in doing that. And just to kind of get a little bit of grasp of how an explanation would look like and how difficult this is. Here is a position that maybe some chess player could appreciate. It's from one of Bobby Fischer's games. This is taken from his book, My 60 Memorable Games. And this is an explanation that Fischer is giving. And again, this is considered one of the classic great chess books, among other things, because of Fischer's clear explanations. So basically, the black king is being checked. Somehow to get out of the check, you can either do it with blocking a piece or moving the king. Ideally, you would not like to move the king. You lose your castle right. The king is stuck in the center. But you can block it with your bishop or the knight, but as Bishop points out here, he gives very kind of very few kind of variations where you're basically, if I do this, you do this, and basically saying it, and okay, you don't want that, but you will end up with a bishop versus inferior bishop versus a knight. So that's not a good trade for you. And then that's because you cannot do that. What you would like to do, you have to move your king, and you can do either here and here. And this is better because of this. This is something that we could learn from, we could understand, even though we maybe don't necessarily agree. But this is something when we are reading over annotated games or something, we do. This is what we learn from. This is how you learn from studying what others have been doing. If you have a computer analyze this position, you just get like here. You see kind of a first consider a move where it's blocking it, but then you end it and say you cannot do that, and it moves away, and then they give us some numerical evaluation, but this is not very helpful. But
Okay.
yeah,
It's great. Yeah. You have it.
yeah, and so, but there have been some attempts at doing this, and Decode Chess is a commercial site that's been trying to do this, but the state of the art is so poor. It says, okay, the explanation is basically, I want to move my king because then I'm tracking to move my king here, check, and take the bishop. The move that it made has nothing to do with that. It just so happened to be another threat in the position. There's no reasoning. But this is the state of the art now. Absolutely useless. And this is something we want to change. And there are many challenges in doing that. And even though we're not going into the tutoring interactive system, just let's say we want to annotate a game so someone can read it and benefit from it. And just to know, like we have to know who's reading it to decide on what sort of annotation to do. We also have to know what are interesting, like during the game, you don't want to annotate every move you make. You have to find those that are of interest. And just that is difficult on its own. And then how do we combine the search and model interpretively? You could, like Fisher did this excellently, gave very short variation and said, okay, now we just have a worst minor piece. Don't have to analyze this further. Just doing all these things are still challenges, like new research challenges for us, and something that I think we can address, like board games / chess. I think is an excellent domain for doing that. And again, and then we can go even further, like the game I was mentioning, where we're not just explaining something that should be known to others, we are actually teaching humans something they don't know. So there are many things to do, and I think I just end with that. Already running late.